Hi, I'm Dr. Paul Mason, and I'm going to speak a little bit about eclipses. And there are two types of eclipses. For the moon, we have the lunar eclipse, and for the sun, we have the solar eclipse. But they are very related, and the fact that we have one means that we have the other in fact. But the solar eclipse can occur only during the day. For the observer, can only see it during the day. It's when the moon at the phase of new moon blocks the sun, and it could be part of the sun or all of it. The lunar eclipse occurs at night. It occurs when the moon is at full moon only, and it's when the moon passes through the shadow of the earth. Solar eclipse, part of the earth passes through the shadow of the moon. So in this picture of the lunar eclipse, we can think of the motion of the moon. The moon is orbiting around the earth is spinning, the earth and the moon are both orbiting around the sun. So we can imagine all of these things, but we can reduce it down to thinking about the motion of the moon through the shadow of the earth. So there are three types of lunar eclipses and two shadows. The two shadows first are the umbra, which is the main dark shadow. Anything in the umbra would be in total eclipse and not see any part of the sun. If you're in the penumbra, over here, outer region of the umbra, then you would be able to see the sun, but only partly. Anywhere outside the penumbra, you would be able to see the sun completely. And this works for either the solar eclipse or the lunar eclipse. In the case of the lunar eclipse, we could have a total lunar eclipse where the moon is in the umbra, as shown in the diagram. You could have a partial lunar eclipse where the moon is only partly in the umbra, and this could occur either because the moon is moving into the umbra and a total eclipse is about to occur, or a partial lunar eclipse could be from your vantage point, in the case of the moon not being quite lined up with the earth. A partial lunar eclipse may occur, and no total lunar eclipses could occur in that case. And likewise, if the moon only is in the penumbra and does not get in the umbra even partly, it's called a penumbral eclipse. And a penumbral eclipse looks a lot like a just kind of a little bit slightly darker moon, and hard to tell that it is in an eclipse if you didn't know. So in January 2018, there was a lunar eclipse. This diagram on the left shows the shadow and the umbra and penumbra of the earth and the moon moving through it. On the right, we have a photograph, actual photograph of the moon. And we can see why it's brighter down on the lower extremity here, and above it's dark, very dark, and that's because of the location of the moon as it was in the umbra. The part of it that was nearest the edge of the umbra was the bottom part here. We can see an animation of that same eclipse and the same effect here. So it passes in through the penumbra first and then into the umbra. So we have two shadows. We have three types of eclipse. We have the total lunar eclipse, the partial lunar eclipse there, and then the penumbral lunar eclipse. For solar eclipses, we can see that the moon is much smaller than the Earth, and because of that, the moon is not capable of covering up the Earth, or the Earth is not able to be completely in the shadow of the moon. But we still have the umbra and the penumbra, and part of the Earth is in the shadow of the moon in a total eclipse. So we have a situation, something like this, where in this small region there would be a total solar eclipse, and in regions further out we end up having more and more of the sun is visible during the eclipse. So we have partial phases of the eclipse. So there are three types of solar eclipses. Again, the same two shadows. We have the umbra, the dark shadow where you cannot see the sun at all. The penumbra, over here you'd be able to see this side of the sun. Over here you'd be able to see the left side of the sun. And there's the antumbra, which is where you have a annular eclipse. This is B. A is the total solar eclipse. The moon completely covers up the sun. And here we have an annular eclipse. And here we have a partial solar eclipse. The annular eclipse is interesting because it's in these cases that the moon is slightly further away than average from the sun. And because of that, it appears smaller in the sky and is not able to block out the whole sun. And so the total solar eclipse case, that's where you have the moon a little bit closer than average, and it is capable of covering up the entire sun. Partial eclipses, solar eclipses, can occur either as on the way to being either one of these types of eclipses. So we have some pictures of a partial and an annular, a total solar eclipse, and then the diamond ring effect. And the diamond ring effect happens when the total solar eclipse, you see the corona here just before or just after perfect totality, where none of the sun is seen, completely covered by the moon. You can see the corona of the sun. Just before that, you can see just a very small amount of sun peeping through, and that's called the diamond ring effect. Here's the annular eclipse, and the moon is a little further away than average, and here's a partial solar eclipse. So that's eclipses.